Hello, this is Jeongbin's study room. The moon is the celestial body closest to Earth. There are many fascinating phenomena related to the moon, and today we are going to learn about lunar eclipses. A lunar eclipse occurs when the moon enters Earth's shadow and becomes invisible. Today, we will calculate the period of lunar eclipses using the angles derived from the distances between the moon, Earth, and the Sun. The orbital period of the moon, which revolves around the Earth, takes about 27.212 days. This means it takes approximately 27.212 days for the moon to complete one orbit around the Earth. During this time, the moon roughly traces a circle around Earth, called the celestial sphere. The Sun, with respect to the celestial sphere centered on Earth, has a period of about 346.6 days, forming an apparent path around Earth called the ecliptic. For a lunar eclipse to occur, the Earth, Moon, and Sun need to be aligned. However, since the orbits of these celestial bodies are not perfect circles and are slightly tilted ellipses, such alignment is rare. Alignment implies that these bodies are on the same plane. Let's assume the moon can be at various positions on this plane. This diagram represents the distances between Earth, the Sun, and the Moon. In this case, a lunar eclipse is defined as up to this position. From this position is the threshold that determines whether a lunar eclipse has occurred or not. Considering the sizes and distances between Earth, the Moon, and the Sun, the angles between Earth and the Moon, designated as A and B, are found to be 0.253 degrees and 0.692 degrees respectively. For a general lunar eclipse to occur, the angle between the line connecting the Earth and the Sun and the line connecting the Earth and the Moon should be 0.945 degrees or less. This condition means that the moon must be within the range where Earth's shadow can reach it, allowing for a partial or penumbral eclipse to occur. A total lunar eclipse occurs when the moon's relative position is exactly as shown. As seen in the diagram, for a total lunar eclipse to occur, the angle between the line connecting the Earth and the Sun and the line connecting the Earth and the Moon must be 0.439 degrees or less. In this case, the Moon is entirely within Earth's umbra, resulting in a total lunar eclipse where the entire Moon is obscured. Because a smaller angle is required, total lunar eclipses occur less frequently than partial lunar eclipses. Now, let's calculate the period of lunar eclipses. Based on the conditions for a lunar eclipse, we need to determine the least common multiple of the rotations of the ecliptic and celestial sphere, where the Sun, Earth, and Moon are aligned, placing the Sun and Moon on opposite sides at positions A and B. To figure this out, you multiply 346.6 by 19, which gives you about 6,585.4 days. Then, you do another multiplication, 27.212 times 242, and that comes out to about 6,585.3 days. The Saros cycle, which is the cycle for both solar and lunar eclipses, is approximately 6,586.3213 days, or 18 years and 11 days. This is very close to our calculated results. By understanding the angular conditions and periods of lunar and total lunar eclipses, we can predict when eclipses will occur. Did this video help you understand the period of lunar eclipses? If you want to know more, please visit the link in the comments. I'll be waiting for you at Jeongbin's study room.